Good afternoon, participants. Kindly wait for 2 more minutes. Other participants can join. Thank you. Good afternoon, everyone. I heartily welcome all the participants for the 5 days FDP on AI-driven cybersecurity in smart devices, organized by IAQ and Department of Computer Science, Sri Kanniga Parameshwari Arts and Science College for Women, Chennai. The Committee of Management SKPT founded Sri Kanniga Parameshwari Arts and Science College in 1999, and the foundation stone of the college building was led by the Education Minister Mr. K. Anbalagan, and he also graced the inaugural function. And the institution is reaccredited by NAC, ISO certificate obtained 2F and linguistic Telugu minority status. About the Department of Computer Science, it was incepted in the year of 1999, and PG courses in computer science was started in the year of 2016. It consists of dedicated team of staff members striving to tap the hidden talents of young minds. The department is well equipped with a computer lab and digital and microprocessor lab. And many of the computer science students are placed in the companies like TCS, Accenture, Infosys, and HCL. And heartily welcome our today's resource person, Dr. Jayalakshmi ma'am. She is a senior assistant professor at Amrita Vishwa Vidyapeetham, India. She is a PhD in Information and Communication Engineering from Anna University in 2023. She has published in several reputed international journals and conferences. And her area of interest include artificial intelligence, machine learning, deep learning, data analysis, social media analysis, healthcare analysis, etc. Welcome you, ma'am.
Thank you, ma'am. So let us delve into the session. Is my screen visible?
Yes, ma'am.
Okay, so this is a discussion on AI-driven cybersecurity and smart devices. I welcome you all to the session. So this is the agenda for today's discussion. We will discuss a little basic on network security, firewall, system auditing, and the need for the focus is on
Ma'am,
AI
kindly
ML.
make your screen full screen, ma'am. It is in half screen. My participants not visible, ma'am. You may proceed in full screen, ma'am. Thank you, ma'am.
Is it visible, ma'am?
Yeah, ma'am, it is visible.
Yeah. Okay. So this is a presentation, the agenda of the presentation, which goes with network security basics, firewalls, system auditing, and AML, the integration of AML into smart devices and networking. So this is the age of smart devices. We have a lot of smart devices in the form of smartphones, IoT, IoMT, and a lot other devices, wearable devices, and so many such devices have hailed their existence, and all of them have started to contribute to data and consume data. So this is the world that we are living in. And the Internet of Things is getting bigger and bigger these days, finding its implementation in manufacturing, in logistics, and many other areas. The Internet of Things is also becoming common these days. We have also a separate genre of wearable technologies, which are largely used for healthcare. And a smartwatch is a very common example. There are a lot of fitness trackers that have come into place these days. Even smart clothing have become a trend in recent days. And this is a image that shows wearable technology into clothing, which shows smart shoes, smart socks, smart pants, smart belt, and literally, if we can integrate technology into anything, we can make it smarter. And this is the scenario of today's era. And what is triggering the expansion? That is a bigger question. The technological advancements, the availability of internet, the battery life, extended battery life, we are able to support sensors with battery backup. A lot of cost reduction is happening, and the functionality is very much becoming general purpose. The need for a pedometer, which counts the steps, is becoming a much common parameter these days, which is increasing the range of usage of these devices. Increased connectivity, the availability of internet in literally even villages is also leading to the revolution. The health awareness is becoming huge, and there comes the place for fitness trackers and smartwatches. Smart and wearables in action, they are available literally everywhere: healthcare, fitness and wellness, smart homes, transportation, retail, entertainment. Literally everywhere we are able to find them in action. And this is also the future that we are leading ourselves into. And this is the connected environment, but is it convenient? It can even be compromised. That is the scenario of our discussion. So, when we have a lot of smart devices also connected to the internet, there is increased risk of uh, attack and hacking by cyber criminals. And when it comes to security, it is also possible that our hardware, software, or firmware is being compromised at any layer. If there is a leak, then there is possibility of leakage of information or even malfunction. When we have outdated, unlicensed software and credentials not being changed very recently, very frequently, that is also a major issue. and insecure protocols. Use of such technologies also weakens the communication. A lot of such issues still persist, and coming to a greater danger if we are having issues with hardware and network, and still there is larger range for loss of information or downtime. So physical access, that is a unsecured physical port over hardware, maybe on a router, a hub, or any such gateway. Anywhere we are having a manipulation, weak encryption, we can have encryption leakages, maybe cracking of encryption, or weak passwords, or leakages by the buffer overflow, or any such hash algorithms, or any such possibilities. Network vulnerabilities, we have such network vulnerabilities maybe via Wi-Fi or any, because one device is being connected with Bluetooth, Wi-Fi, wired connection. So many connections are possible. So the link, a weak link, can be literally anywhere. There is also possibility of side channel attacks, exploiting maybe while we are putting a phone under charge, or we are powering up a device, or maybe communicating with some other device. There are possible side channel attacks. There is anybody looking for little loopholes uh, in the electromagnetic signals, and therefrom, not with encryption also, but by cracking at the signal level also, they can mishandle all this information. And there is also this human factor. We have phishing attacks, weak passwords, lack of awareness, and malicious apps that are being available in plenty, which, if downloaded, simply can consume on all our money. And this is all human factor, which leads to risks. And there are a lot of people or agents, software agents, which exploit these weaknesses. There are ransomwares, botnets, data breaches, and automatic eavesdropping softwares which may collect your credentials, important ones which may even be related to financial data. And botnets are ransomware. These are gaining huge attention these days because a lot of um, data, not just data loss, financial losses are incurred by ransomware and botnets these days. With the age of cryptocurrency, this is gaining a lot of attention. When it comes to smart devices, we have a distributed denial of service attack, which is possible literally in any network, and which renders the entire network unusable for a stipulated amount of time, and that is going to crash the entire service. So ransomware, data breaches, all these are exploiting the weaker part of that network. So this is a figure that shows the weak links that are possible in a network. So we have a IoT network over here connected to a lot of IoT devices. We have an Alexa, we have users, bots, we have pods, a lot of devices, routers, so many devices connected to the internet, smart TVs, literally everything connected to the router. And you can see from every end there is a risk of being hacked or a loss of information. Here, this diagram summarizes three different clauses of data loss: flooding attack, slow request or response attack, conversion into a bot, converting the regular functionality into a bot. We just do a code injection and we are able to convert any part of the legitimate code into a bot and still hack information. And we can see compromised device bots. So these are the vulnerabilities. You can see the range of issues, the severity of the issues that are prevalent these days. And because of this, there is literally privacy violation, and that is the most uh, unauthorized access and loss of personal data. This is the most horrible thing that can happen. We are seeing every celebrity claiming their account, X account, being hacked these days. So this is all a privacy violation. In financial loss, physical harm, literally anything can be happening, which can lead to huge damage and even damage of reputation in case of people who are literally influential. And strengthening the defenses, that can happen in a layered fashion. And since we are building a network with the OSI layers, the layered security is what we are going to discuss next. The secure device configuration, that is one possibility which we can do. Network security with firewalls and Wi-Fi security, that we can do. User education and awareness is another genre of strengthening the defenses. And manufacturer responsibility with hardware, secure hardware design, secure chip design, that is another genre, but we are skipping the manufacturer section and dealing with the rest. So what is threat detection? When we're going for threat detection, there are so many things that we can discuss. Threat can be identified by several ways. uh, Looking at methods, leveraging threat intelligence can be done with signatures of maybe viruses or the packets, the flow of packets, the pattern of packet flows, the pattern behavior of the data transfer. All this can give us a little idea on some malfunction, some malicious nature. This is looking at the signature part. Analyzing user and attacker behavior. That is also another possibility of finding a threat, detecting a threat, looking at logs, looking at, you can incorporate AI and ML to identify malicious behavior, or attackers' behavior are not going to be similar with a common user, so that we can differentiate with help of AI, and we can go ahead and prevent the attacks earlier. And we can also go for setting honey traps which can lure people to believe that it is a legitimate process, and then we can quarantine them by luring them into the honey traps. And there are threat hunts also that are possible. Coming to threat detection, we have a multi-pronged approach. It can happen in a network or an endpoint. So these two are the very common things that we usually do. But even beyond security, even threat detection can happen literally anywhere in the OSI stack. So this is multi-pronged approach. And this is security through obscurity. So what is obscurity? By means of enforcing rules, secrecy and confidentiality, by passwords, by authentication, encryption, literally everything that is possible with firewalls, that is obscurity. And this is what we are all aware of, the TCP/IP protocol stack. So we can see the network interface layer, the protocols that function under the regime of network interface layer, the internet layer, the transport layer, and the application layer. And over here, we can see the very common protocols and their functionalities. We can do the network translation in the internet layer, and the mapping of the public and private IPs which happens there. The error messages, error detection and messages, those are done with the ICMP packages, and application layer supports telnet, so many such protocols, traceroute, so many such protocols, ping, which support detection of malicious components. And this is a common OSI layer which gives where we can have the vulnerability in physical layer or the data link layer or the network layer or transport layer or application layer. So the vulnerability can be literally anywhere. And the compromise, if it is done in any of the layers, it is going to bring down the whole stack. So this is the issue with the layered approach. And when it comes to IP spoofing, impersonation is happening, and a person impersonates to be another. The IP of a legitimate person can be spoofed that way. And when it is spoofing, there are several types of spoofing. It can be a DNS server spoofing, or ARP spoofing, or an IP address spoofing. So over here, we are trying to impersonate the server itself, or the ARP MAC addresses, or the IP addresses, the origin, the destination, anywhere we can manipulate. All this can be spoofed. And this is a IPv4 structure, a packet header structure, which shows lot of such information. The uh, important information in packets like the TCP sequence numbers, the uh, checksums, all these can be manipulated in order to manipulate the system. So this is the lower level of attack and the vulnerability that is possible. So the IP address spoofing can have can lead to denial distribution, distributed denial of attacks, denial of service attacks, which can be uh, to the upper level mask the availability location of botnets, or it may have a projected staged result, a stage by stage. It can fail few components at a time. That is also possible to attack in a layered fashion. So TCP three-way handshake, when it comes to picture, that can also be manipulated. The three steps of the three-way handshake are given here, which is a handshake causing a synchronization. So the visitor sends a synchronized packet to a host, and the synchronized acknowledged packet has to arrive, and then the visitor acknowledges the receipt of the acknowledgement of the synchronization back again, replying with an acknowledgement packet. This is the sequence of steps, but the third step, if it is manipulated and by someone, if it is hacked and this message alone is modified, it can redirect further communication to a different person altogether, which may lead to spoofing. This is also a key loophole in the handshakes. So, anti spoofing with the deep packet inspection, it is possible to avoid spoofing and the denial of service attacks. So, with TCP sequence number attack is shown in this figure. A malicious user is trying to hack into the packets and change the sequence number of the packets in the TCP headers, which can also avoid the proper comprehension of the information and misinterpretation of the information. So, the anatomy of TCP sequence prediction attacks, that is also done by an attacker continuously observing a communication and the sequence of a communication, the packets, packet flow, traffic flow, trend of traffic flow, all this. So this is all possible. So measure to prevent the TCP attack that is being accommodated by larger forces like IETF, by introducing new standards, renewed standards, which are like now banks are asking like very frequently to change the passwords of maybe UPI or the account NEFT passwords. So much of new standards with security are coming up. Security standards are being renewed, and they are strengthening the grounds, but still the so is the attack becoming stronger. There is also a possibility of UDP flood, which is also leading to the denial of service, like attacking the UDP packet or just flooding a server with UDP packets. That can also lead to a denial of service attack. So, how do we mitigate all this? By observing the response rate of ICMP packets, which are determined to cause a denial of service. By introspection of these packets, type of packets, identifying the malicious flow, we can definitely avoid the attack. So over the period of conversation, we have been discussing about several types of attacks, and we discussed that by observing the traffic, types of packets, types of behaviors, we are able to prevent or classify malicious behavior. And there comes the use of machine learning and artificial intelligence in enforcing security in devices, smart devices. And I would make it generic to literally any device. And when it comes to NIC cards, the NIC cards, the network cards, if we are interfacing a computer to a network, when we are installing the sniffing packets, then also vulnerability is possible. We can have hardware sniffers or software sniffers. By hardware or software, we can go for sniffers, and sniffers can be used for both purposes, for protecting uh, the systems or just uh, misusing the information to wage a war. Now, packet filtering is another thing. Like firewalls, we are trying to uh, filter the flow of traffic, filter the packets. This can be done with routers or hardware firewalls, literally anywhere this can be enforced. And the advantage of packet filtering is there that on screening, the router, the entire network is safe behind it. So there we can install packet filtering. Packet filtering is not going to require much of knowledge about the whole network and the size of the network. Packet filtering at the router is the best thing that we can do. Or we can go for installing a firewall. And the disadvantage is that it is not complete, it is not perfect, and some protocols are not literally suited for packet filtering. They can still bypass the filters, and some policies uh, can be drafted to enforce a stricter security. If weaker, it can be manipulated. And these are firewalls. So firewalls are going to filter out the malicious packets or softwares. It depends upon the configuration of hardware or software. We can have hardware or software firewalls. They can be doing any of these. They can be doing packet filtering or over the application gateway using technologies like FTP and Telnet servers. They can enforce security, or at circuit level gateways, they can enforce security by looking into TCP UDP connection establishment and the packets which are being transmitted. Or you can have a proxy server doing the job. And firewall utilizes all these components in order to enforce security. You can have a static packet filter, a dynamic packet filter, which is also state aware or a circuit level gateway, or you can have an application level gateway or a stateful inspection, or you can have a cutoff proxy or an air gap. We'll see one after the other. This is a static packet filter. A static packet filter, which installed, will look each packet, disallows those packets that it finds to be malicious. They are not from the proper source, they are conflicting with the header. All these will be just blocked at the this end. The advantage is it is having very less impact on network performance. It is very low cost, and is the best thing we can do. And coming to the disadvantages, we may have to examine exhaustively every packet that is passing through. That may be sometimes not very much possible over a system like a server or a router. Unaware of packet payload, we if we are not understanding the purpose, the nature of the protocol and the purpose of the application, we may render the security to be less secure. And coming to IP spoofing, that is also possible to be incorporated in these systems which involve filters. The dynamic packet filters can monitor the connections in real time, and they can go ahead and determine which packets are allowed by the firewall, which are not allowed by the firewall. They are also the most feasible options which are cost effective, and they operate in every network layer. That is the biggest advantage. And again, they can be rendered to IP spoofing. They can be subjected to IP spoofing. And there is a circuit gateway, circuit level gateway, which can also be a victim of IP spoofing. This is session layer 5, the OSI layer 5, where the gateway is active. So this also goes with certain policies for filtering the traffic, and this is also not going to affect the network performance, and this is behind the firewall. So this disadvantage involves the same which we have discussed earlier in packet filters. And coming to application level gateways, in application level gateways, we can install softwares or proxies in order to filter the traffic. And the advantages are better logging of traffic, better understanding the nature of traffic. We can offer a much higher level of security. We can create strong application proxies, and the major issue is its complexity. So this is what we look at in application level gateway. In application level, the information from the internet goes into the local system. In stateful inspection, stateful inspection, we are going to combine the dynamic packet filtering, the circuit level and application level gateway. Several things are being combined, and we are trying to infer the state information about combining, like what is the state of past packets, now which packet is coming, and what will be the nature. Such analysis is possible to be done with the states. A unique limitation is that the ability to inspect sequence number, as we discussed earlier, NTCP sequence number hacking. So this, when done on packets, maybe incoming or outgoing, these are also going to prevent from the attacks which involve sequence numbers. So it is going to offer even lower level of security. At the lower level of ISO OSI layers, it is going to offer security. And advantages, it is able to inspect literally all 7 layers, and it is going to create a fail-proof model. The disadvantage is that it is single-threaded, and that may affect its performance. And there is also another unit called an air gap. This air gap is a kind of firewall. It's a kind of firewall or a system which is going to automate uh, the possibility of trust enforcement with the help of the system is possible. We are going to use this system air gap. This is between the outside and the internal network. So whatever network comes through, it is going to store in a SCSI disk and then analyze them and then do the filtering part. So that is also very much possible in air gap. And system auditing, it can be done literally by anybody, internal, external, manual audits or automated audits. So there is also a lot of standards organizations like ISO, HIPAA, all these people playing their wide roles in enforcing security standards. And there is also OWASP for web application security. When it comes to web application security, the scenario, the cards are different. We have a web injection, SQL injection. As an SQL injection, we have web injection script is injected with certain code which can lead to malicious nature of behavior. Broken authentication is broken here. Sensitive data exposure, which is leaked out data. XML external entities. When we have external entities over XML, and there is a weaker security at the parser level, it can be wrongly used, broken access control. So we are trying to breach the access control. Security misconfigurations are also leading to the issues, and cross-site scriptings with XSS protocols also mean there is a bad actor, malicious one, which is modifying the scripts in the web application and thereby manipulating the web application. Insecure deserialization. Insecure deserialization is about interacting uh, interaction with the web server or the web application can happen with anybody, and that is where the bad actor is located. It will interact with the web application and for a malicious purpose. It may be from URLs. For example, by clicking at some link, we are losing our money. So such is an example. Using components with known vulnerabilities. Uh, if in instances like missed software, updating, installing softwares which are not licensed, such also can cause issues. Insufficient logging and monitoring. This is also leading to web application issues. And when it comes to protection of web applications, can be passive or active. Passive protection and active protection differ in only one thing. Protecting against the browser data exfiltration, that is, browser data uh, modification of the scripts and bugging them. So that is active, avoiding it by incorporating certain filters. That is exfiltration. And the passive protection is more like static approach. And even in real time, we can enforce notifications on some um, improper access. And there is also possibility of intrusion detection systems as software or hardware being deployed to uh, filter out malicious traffic or detect malicious access. These can be either host-based, network-based, stack-based, or signature-based, or anomaly-based. This is an example. Every virus has its signature. If we have a ML database, ML trained code, you can go ahead and differentiate between a normal signature and a viral signature and find a attack. And when it comes to design of SIEM, security, information, and event management, this can be done with the help of so many tools, Elasticsearches, Cloud SIEM, and a lot of ML tools like Kibana is available for visualization. A lot of Elasticsearch, such cloud tools are also available for this purpose. AI systems also will help in real-time detection of malicious users or softwares. And when it comes to machine learning for cybersecurity, the machine learning starts with data and their features and the algorithms that extract the features, use them well, and find out decisions, frame decisions. So when it is data mining, it is a combo of data and algorithms. When it is data science, it is data and features. And when it is ML with a little bit of all of things, it is classical programming. A lot of algorithms are there which will help in uh, the process of classifying threats or quarantining. Quarantining is a technical term which is, for example, we have a honey pot wherein we are trying to have a temporary area, a different area where a software is installed. If it is malicious, it is quarantined. If it is okay, it is the change is allowed on the permanent system, original system. So this is how honeypots and the uh, quarantining process works. We'll see the demo after we finish of the discussion about how we are able to incorporate with ML the possibilities of security in IoT devices. So we can have regression and classification. So classification over numeric data is called regression, and we can do clustering, which is literally segregating the classes of maybe victims or types of attackers, or malicious programs. Association rule mining is for recommendation, drafting recommendations in order to provide some sort of service to the user. For example, product purchase or purchase of clothes. Dimensionality reduction. It is a wide area about reducing the number of dimensions that we are dealing with by maybe transformation or normalization or any other algorithms like PCA, uh, principal component analysis. Excuse me. There is possibility of generative models, which are very trendy these days, which can go ahead and filter out knowledge and thereby match attacker or classify attackers. So machine learning tasks in cybersecurity will involve cybersecurity with systems or IoT devices or wearable systems. Literally, the device can be anything, but the process is going to be one and one only in AI ML. So we can go for regression, classification, association, rule mining. Thereby, we are able to extract the why part, the what part, and the how part. Why it happened, causal analysis, what happened, did breach occur, was there any malicious information, and how it occurred. So all these is possible to be drafted in this. In security tasks, they are divided into prediction, prevention, detection, response, and monitoring. So the what section answers like the technical layer, where exactly, what exactly are we dealing with, where exactly the breach happens. Such information can be filtered out. How is when the security breach is happening, how is a security check is happening, that answers the how part. Are we addressing a packet which is passing through a network or at rest, or we are dealing with archives, heuristic information. And this is machine learning for network protection. We can have network packet parameters. We can compare them with the original ones, normal ones, and then find out if there is any malicious access to the system, malicious traffic in the system, and classification to different classes. There is possibility of different classes in network attacks. So we can classify them or we can cluster forensic analysis. Everything is possible. And when it is machine learning for endpoint protection, regression to predict what further, what next action will take place in order to manipulate the system following a malicious behavior. That is also possible in endpoint protection, prediction, or even classification, malware classification and quarantining. That is also possible in endpoints. So when it comes to application security, you can still install softwares and avoid this. There are web applications, databases, ERP software, SaaS applications, Microservices, literally all types of softwares are there. And when it is involving you ML models, machine learning models, These can avoid or find the threads in time and avoid the manipulation, misinterpretation, or failure of the entire system. ML can be applied to maybe even HTTP requests as in web pages or SQL injection attacks, or you can even go for clustering in order to classify if this is a DDoS attack, distributed denial of service attack. Machine learning can be subjected to even process behavior. The process behavior can be assumed, and if it is fraudulent or normal, that can be classified from therefrom. And when it is deep learning in cybersecurity, you can go ahead and incorporate deep learning algorithms, RNN algorithms, in order to perform the same job of intrusion detection. And malwares can be classified based on their signatures, deep learning with deep learning algorithms, and any sort of suspicious behaviors also can be found out. Uh, Classification of spam and ham emails or social engineering detection. That's also possible with the help of traffic analysis. When it comes to traffic analysis, we can observe every packet that's passing through and find out if there is any attack and what is the class of the attack. And for all this, we have AI as the one rescuer, which is becoming pervasive these days and also powerful these days, which is also even dictating the supremacy of countries. And when it is AI, we have cyber attacks and attack methods, which are very much increasing these days. Just having a few type of attacks that can be classified manually, but if we have too many types of attacks and viruses, trojans, all these things, it is not literally possible to do a manual calculation. And in the years after 2019, many people have fell in victim for such fraudulent behaviors. And when it comes to threat, when it is when it is compute when it is about the threat landscape, when everything has gone digital, every damn thing is smart device, then the threat landscape becomes even much bigger, and that is when we need AI to automate everything in huge in size. There, AI becomes legally needed. Zero-day exploits, like these are attacks, zero-day exploits are attacks which are literally not perceived by the developer, which can be happening at any point of time, which will affect the system behavior. This is a zero-day attack, and this may render the service unusable or may be leading to loss of information. So, of all these kinds, we can have the losses. And when it comes to frameworks incorporating AI, machine learning and deep learning frameworks, transfer learning frameworks, or trained networks, those come to the rescue. And when it comes to incorporation of AI, it can be used literally in automobiles, computer applications, agriculture, machine, medicine, cybersecurity. And when it comes to machine learning and deep learning, we see a wide range of applications involving machine learning, deep learning, supervised and unsupervised learning. Supervised learning happens with labeled data, and unsupervised learning happens with raw unlabeled data. And explainability and challenges. When it is coming to obscurity of AI systems, how we reason with the decisions and we make the predictions that needs some explanation. With explainable AI, which is also becoming much cheaper these days, data poisoning attack is also very much possible, which can be prevented with the help of such explainability issues and all. Zero day attacks are becoming much costlier. Just issues like multi billion dollar loss are happening these days because of zero day attacks, and very few to not are based on ransomware. Attacks have been given here. RSA attack, which happened on Adobe Flash, that is a major attack. Sony hacks, which created data breaches in Sony systems, that is another major attack. And so many different types of Trojans, viruses, polymorphic viruses, all this is emerging. Polymorphic viruses change their signature, and that becomes hard for us to detect them. So the method is just about to classify malicious content uh, and go ahead and prevent them, or classify them and quarantine them. So when it comes to traditional cybersecurity techniques, signature-based techniques are becoming have been used for a longer time, which have a major challenge. If it is, for example, a polymorphic one or a malware, it becomes hard for us to detect the signatures. It keeps on changing the signatures. Anomaly-based detection, there the challenge is about high false alarm rate when we are tagging a packet, maybe a packet malicious. If even for a good packet we are giving a malicious tag, in that case it is a false alarm. If this keeps on happening also, it is a bigger issue. And proposed strategy is one of these. We will go with an example. This is a collab notebook. This is a collab notebook. I think it is visible. Make it a bit bigger. So this is incorporation of machine learning algorithms for classification of malicious traffic. So what do we have here? We have a data which is randomly generated though for a test purpose. So we have a packet size, duration, destination port, and byte sent. And we have 1,000 samples automatically generated. We have given the seed value for the random function, and that's doing the job, and it is creating 1,000 samples. Okay, so we have engineered the features, and then we are going for feature engineering. We are creating bytes per second speed, so bytes spent by duration that we are calculating. And here is the data. So we are seeing the data, the sequence, the packet size, the duration, destination port, bytes sent, bytes per second. This we have calculated. So here is the assumption. So we have a system communicating to the other via port. So port for source and destination are different. We have a packet size for each packet. We have protocol list item. Protocol element plays a major role. And now we are going to use isolation forest algorithm, which is a clustering algorithm. So we are splitting to training and test set. We are applying the isolation forest algorithm, and we are trying to make some parameters which are anomaly scores and predictions. So we are creating something like this. So we have packet size, duration, destination port on the host port, and then we have this. anomaly score and prediction. So this we have done. So a prediction of 1 says it is a normal packet, and if it is -1 it means it's an anomaly packet. So we have created a data set. This is a confusion matrix for the test data. It shows classification. So we have seen how we have collected the data. It can be collected from the packets or the devices, or features can be engineered. So any of this can be done. And we have some data in hand now. We choose proper model. This is the deep learning model, the isolation forest, which we have discussed just now. It's for clustering. We can do just a second. We can do installation of a package called SCAPI. This is actually a package which is meant for manipulating the security credentials, monitoring the packet traffic, packet capture, such things can be done with SCAPI. This is a package. So over the first section, we saw how ML can be used for classifying proper and improper traffic. That we saw earlier. Now this is another piece of code where we have event types like login, file access, malware detection, unauthorized access, service restart, configuration change. I'd like to show you the dataset. For test purpose, I have generated everything literally myself. This is automatically generated. So here is the timestamp, here is the status. It's a warning, error, or an information. So first one says it's a warning. It's a service restart, and this is service level 7. The second one is also a warning. The third one is an information. It's a file access. Somebody is trying to access a file, and this is an error. This is an error which says it is an unauthorized access from this IP. So this is the sort of data set that is being created now. So with these statuses, events, all this, we are creating a file. So this is the first section. We created a file called system logs. Now we are filtering out all the error logs. If there is an error on the status, this one. So if there is an error, we are filtering out. So this is the second part. So we have the result of the filter of the error packets. These are all error messages. Malware detected, user logged in from this IP. This is a malware. Unauthorized access attempt. This is just an attempt. file accessed. So many such error messages are there. And now this is a input sniff. There is a package in SCAPI called sniff. Packet sniffing. We discussed about packet sniffing. So the idea is if it is a IO device, IoT, or just about any device, smart device or anything, we are going to incorporate all these same techniques. So if there is a sniffer, now we are going ahead and looking at the packet summary and we are printing it. This is how it looks. Ethernet packet transfers. So we are installing SCAPI. Now over here again we are trying to configure. See, this is all automatic data set generation. So we have three types of data protocols: TCP, UDP, and ICMP. So we have three different protocols. So we are trying to create packet headers here. Packet capture key is given here, which I have to configure over the key section here in order to use packet capture. So those error prone packages are filtered here, and this is the confusion matrix. This is a package VTAPI 3, which is used for analyzing the packets. This all goes with simulated data. Now, if we come across any malicious IP, we are going to block it. This is simulated blocking of IP. And this is quarantining a file. If there is any malicious file, we are going to quarantine it. Where there is, this is Google Drive. Here I'm trying to show. So we in the drive we create a folder called quarantine, and there we try to move the file from the directory to the quarantine folder. See, it is not connected. Okay, just a second. Let's share on with. We start out with the next section. So we saw a sniffer how it works. Sniff the packet, the callback count is given, so 10 packets are being shown here. So this is a sniffer code that we saw here. We'll install. That thing. So there's nothing here except for the sample data. Now I'm running one after the other. We were trying to generate a file called system log. This is installation of SCAPI. And the related packages. So we are creating system log file. Once we run it, the file came. This is the content of the file. As I showed you, it shows you log information, the status, the event type, what information we have here. Everything is being shown. And now we continue. So we load this file, read it, and we perform sniffing over the packet and find out if there is any issue with the packet. This is packet capture, a package, a feature in the package SCAPI for packet capture. It is enabling it to be true, and this is enabling it to be false, just showing how to manipulate it. So this is capturing the packets. I'll show you the output of the packet capture. Now this is a key which we store in the Google Keys. We install a package, we load a package VTAPI, and here we are able to quarantine files if if we find it is malicious. So for doing this, I have created one file to be malicious in nature. I have branded it malicious. So I am choosing it from my folder. This is the file. It is a simple file which I brand to be malicious just for showing the demo. Now I find it in my folder. See, it is here. The packet capture is showed here. The sniffing that we did with the sniff feature, that is stored in capture.pcap. And here is the file. And then quarantine folder, as I told you, it is created with this malicious file. We have it to be malicious, so it is moved to it. One folder called malicious quarantine is created, and the malicious file is actually moved from the content folder in the drive to the quarantine folder. Once we load it, it will be only in the content folder, but now then it is getting quarantine. This is the quarantine piece of code. See, initially when you are loading it, it will be only in the drive, but then this is where the folder is getting created in the drive and the file is getting moved there. This is creation of the folder. This is moving of the file to the folder. That is happening here. So this is showing how files are getting quarantined. So if AI is there, it is powered by automation. All this can happen automatically. So this is showing the usage of ML and AI for security purposes, like how we can perform sniffing, how we can do the quarantine, how we can incorporate ML algorithms for classifying good and bad packets. All this is being shown here in this demo. So the basic packages can differ. This is one little package that I have shown, Scapy. Just scrolling down. So just a second. So this is Cappy. This one package we have dealt with today, but there are n number of packages. Each comes with its own features. With AI, literally, they can make IoT and medical devices. If they are at any level, you can also manipulate them and sniff them, automate, and notify if there is any security breach. So that is possible with AI, with any of these algorithms. So that is the crux of our discussion. So coming back, we just discussed the layers of the stack, its structure of packets, the type of attacks that are possible in the IoT and the medical devices, biomedical devices, and we went ahead with the prevention techniques and how AI comes to the rescue. Because when the data is huge in size, AI can be the only best option for doing any of this classification of the malicious attacks or going ahead and uh, giving alarms automatically if there is any breach. So all this can happen with AI. So these are the proposed strategies, but still there are uh, challenges. We can have supervised machine learning models or unsupervised machine learning models. In supervised machine learning models, the power is our data. We have heuristic data. With that, we can train the target labels and we can go for classification or maybe prediction. But the challenges in supervised model is that when we are having new malware which is not there in the trained data set, then we fall into a dilemma in classification. And precise classification models for this purpose with very much higher accuracy, that is depends, it is subjective. And when it is unsupervised machine learning model, unlabeled data sets are used, and techniques like clustering and so many other unsupervised techniques are also there which can go for classifying attacks or malicious users or patterns. Everything can be done. So when there is vast amount of uh, data, definitely, or any of this is possible. Detection, classification, all this is possible. So this was the crux of the lecture, and if there are any queries, we can have a discussion. I hope it was useful with the demo. Any queries you have, you can ask. Uh, are there any queries?
Participants, if you have queries, you can ask now.
If there are no queries, we will just close the session.
Thank you, ma'am. Thank you for the excellent and informative session.
Okay, ma'am. Thank you, ma'am. Thanks a lot. I thank all the participants for joining the session and paying all attention. Thank you. Thank you all. Bye bye.
I would like to thank all the participants for listening to the session patiently. Thank you all.